Okay? I say several times, I don't like this background. Okay, now, suppose we have a combination. This is a horizontal acid. This is also horizontal acid. And we have vertical acid here. Sometimes we have both, no? So the function look like that. Maybe, like that. Okay. And another possibility is, suppose we have a horizontal acid again, horizontal acid. And we have a function like that. Look. This is one possibility, interesting possibility. Approach, pero no evento. However, in one point cross. This is a crossing point. Entonces we need to investigate see we have a crossing point or no. And the vertical acid, never we have a crossing point. We never have crossing point because in the vertical acid the function is undefined. It's impossible. But in the horizontal sometimes, not always. It's seldom happen, but happen. Okay, let me try to explain the idea for the how you find the horizontal. It's a little bit complicated. Pay attention, please, because we have we have two cases. The case one, I call regular case. Regular case is when the degree of the polynomial in the top is exactly the same of the degree of the polynomial in the bottom. Let's see one example. Example one, same degree. Suppose the function g of x equal, suppose the polynomial in the top is 7x squared plus 2x, and the bottom is 4x squared minus 3. Es obvio que the degree, okay, and the polynomial in the top is 2, because the exponent is 2. This is the clue, right? And likewise, the degree of the polynomial in the bottom is 2. When the degree is the same, 2, 2, 3, 3, 4, 4, 1, 1, 0, 0, yes, it's a regular case. It's a regular case. And the answer is yes. We have horizontal acid. Okay, but this is not totally the thing we need to find. At what value? At what value is the horizontal acid? Well, at y equal, and you take the coefficient, the leading coefficient, the coefficient que contain the higher exponent, you take 7 over 4. This is my horizontal acid. It's a line, a horizontal line, and you take the ratio between the leading coefficients. The reason is clear. The reason is clear. The reason is, si the supposition is que x approaches to infinity, the dominant term in the expression is the expression que contains the higher exponent. So you can completely neglect, this is 2x is completely negligible, you ignore this, and you ignore this. And the function stays 7x squared divided by 4x squared cancel and stay 7 over 4. Okay? And this is the way to find the horizontal acid. Okay, this is the case number one. Let me try to put two examples to illustrate much better the idea, and you help me to understand this horizontal acid. So to find the horizontal acid, always we are doing the analysis of the degree. See, the degree is the same, we are in front, regular case, and the answer is yes. And you obtain by the ratio of the dominant or the leading coefficiency. Suppose the function h of x, que is 8x squared plus 9x minus 5 divided by 2x squared plus 1. thinking about that. I want to write another example. Example 3. The name of the function is p of x is equal x squared plus 7 divided by 11 minus x squared. What do you think about number 2? We have or no? Yes or no? Yes or no? Answer me. Yes. What is the reason? What is the justification? Okay, we have yes. The answer is yes. Okay, I agree. Why? Because the degree of the polynomial in the top is 2, and the degree of the polynomial is 2. Same degree. We are in front the regular case, que everyone know very well. And the answer is yes. At what value? At y equal, because remember the horizontal asymptote is a horizontal line, and the equation for the any horizontal line is y equal any number. What is the number? Y equal what? Answer me.
4.
4. And where come from that 4? For the ratio a divided by 2. Sabrina, degree is 2. Degree is 2, which one? The top or the bottom? Sabrina?
For both.
Both, okay. Entonces, same degree. Yes, we have. Entonces, now you take the dominant term, que the dominant is the term que increasing faster. Es obvio que the function x squared and the function x both increasing, pero this increasing faster. This is the idea que this is dominant. Okay? Okay, now this is easy. What do you think about the example 3? Yes or no? We have horizontal, yes or no?
Yes.
Yes, again is yes. Because degree of the polynomial in the top is 2, degree of the polynomial in the bottom is 2. The only thing I complicated the thing because I put in different organization, different order, but it's the same. Entonces es 4. F4. Okay, Angel, we are doing now number 3 example. Okay.
Yeah, the chat is coming in delay. Sorry.
Okay. Okay, I understand. Okay, entonces in the number 3 problem, what is the horizontal line? Is at y equal what number?
1.
No. 4 was example 2. It was the division a divided by 2. It was 4. But in this case, what is the division of the leading coefficient? What is the leading coefficient in the top? 1. What is the leading coefficient in the bottom? -1. Okay, I intentionally switched the order to confuse you. So 1 divided by -1 is -1.
-1.
Do you see very well or no? Everyone follow me or no?
Yes.
Okay. And this is the only case here we have? No. Unfortunately, no. We have case 2 of the horizontal asymptote, que es special. Special case. Well, a special case is when the degree of the polynomial in the bottom is bigger than the degree of the polynomial in the top. For example, example 4. Suppose one example in which suppose h of x is equal 5 divided by 4x squared plus 9. Okay, entonces now always to determine the horizontal asymptote, you are doing the analysis of the degree. Always, it's the same. Degree, what is the degree of this polynomial? And what is the degree of this polynomial? What is the degree of the polynomial in the top in that case? Well, we have no x, so the degree is 0. And what is the degree of the polynomial in the bottom is 2. In this case, I can see que the degree of the polynomial in the bottom is bigger than the degree of the polynomial in the top. Therefore, we are inside the special case. In the special case, the answer is yes. We have horizontal asymptote, but always at y0. The reason is y0 is clear. Because the polynomial in the bottom increasing super faster because the degree is the same than this. Que this no increasing, this is stay 5, constant. Pero not necessarily constant. Suppose que I put 5x, degree 1 and degree 2. It's exactly the same special case. When the degree of the denominator is bigger than the degree of the polynomial in the numerator, it's a special case, and the polynomial in the bottom increasing faster. When the polynomial in the bottom increasing faster, it's obvious that the entire function decreasing to 0. Okay? And this is the idea for the horizontals. Do you understand? So this is important. Okay. Let me summarize quickly. Pay attention now. Okay, to analyze the horizontal asymptote, you are doing always the analysis of the degree. Degree top, degree bottom. We have two possibilities. Regular case, when the degree is the same. And special, when the degree of the denominator is bigger than. See, the degree of the numerator is bigger than the denominator is an opposite situation. So we have no horizontals. We have another thing we studied in a few minutes. Okay, let's see one complete example of this. Any question? Any question? Everyone follow me? Clear? Confusing? I understand that this topic is not complicated, but have too many details. Okay? Let me try to put one example, try to summarize the idea for the horizontal and also include a new situation. Look, suppose example 5, no? Suppose the function h of x is equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay. My first question is, we have horizontal asymptote, yes or no?
Yes.
Yes, the answer is yes, because the degree of the polynomial in the denominator is 2, and the degree of the polynomial in the numerator is also 2. Same degree is regular case, no special. Entonces, yes, we have. At what value we have? At y equal?
4.
4. And 4 comes from the division of this coefficient divided by this. Super. Okay, now I introduce a new idea. I want to determine the second step, always mandatory, when you analyze the horizontal asymptote, you need to investigate if my function crossed or no, the horizontal asymptote. Okay, sometimes happens, sometimes no. Entonces now I need to find out if my curve crosses or not the horizontal asymptote. Okay, what is the way? Well, the way is you copy the function, exactly the same. Okay. I copy, just copy, and you enforce it algebraically to be equal 4. Because I want to determine if it's possible or impossible, it's stupid or no, okay, this curve crosses 4, okay, our horizontal. Okay, in that moment we have equation. I try to solve it. Sometimes happen that the equation have solution, entonces cross it. Sometimes happen that the equation have no solution, entonces no cross it. So the hypothesis que I try to prove is impossible or possible. Okay, now you apply cross multiplication. Why not? Multiplication this polynomial, multiplication by 1 stays the same. And multiplication 4 times this. 4 times 2x squared plus 1. Okay, you apply this derivative property here. So we have ax squared plus 4. Wow, my equation so far is, look, ax squared plus 9x minus 5 equal ax squared. This is repeated. We can cancel out. Then so far we have 9x minus 5 equal 4, no? Equal 4, guess this guy. Solve this elementary linear equation. 9x is equal 4 plus 5 get 9. Nice. Divided by 9, both sides. X is equal 1. Like we determine, yes, the hypothesis is true. The function, the curve, crossed the horizontal axis at x equal 1. Because you need to write this point like the order pair should be 1,4, no? Because 1 was the x value we found, and y is the value of the horizontal axis that we enforced the equation to be possible or impossible is 1,4. Okay, super. So now, to illustrate very well this idea, let me try to do my best. Okay, I want to, let's see here. Okay, there you go. I want to switch in the to decimals, no? To decimals. Switching to decimals. There you go, decimals. Okay. Okay, do you see decimals? Do you see decimals? Yes or no? Huh?
Yes.
Yes, okay, good. Okay, this is the decimal is example 3. Look, example 3 is something like that. Boom, look at that. This is the graph of the function. So my function is the red color curve. And we discover that we have one horizontal axis at y equal 4. Look, it's true. Look, in behavior, look at that what happens. I make a zoom. I can see, for example, when the x approaches to positive infinity, so increasing, the curve approaches but never touch. Okay. In the positive direction. In the negative direction happens similar situation. However, specific and the famous point 1,4 cross. This situation happens seldom, not always happen. So basically, in any problem, you need to check in this situation. See if the curve crosses or not the horizontal. How do you know que no cross it? Well, don't cross it because maybe when you solve the equation has no solution. If the equation has solution, it's because it exists the point. See the equation have no solution, do not exist the point. See the equation have solution, like in this example, of course we have a point. This is a special point that you don't need to ignore in the analysis. Clear or confusing?
I have a question. Like, for example, that equation that doesn't have solution can be like an imaginary number?
No. Good question. I promise you see in another example this situation. Not necessarily imaginary. Suppose that my equation is x plus 2 equal x plus 3. Entonces I don't know. I move x to the other side. Entonces 3 minus 2, this is 0 equal 1. This is totally false. No solution. Entonces we have no point. Not necessarily imaginary. Imaginary is another possibility. You are right, but not always. Okay?
Okay, thank you.
Okay, let's move on to the last asymptote that we studied. I promise today at least we are doing one example, one entire example that includes everything at the beginning, que es slang asymptote. Slang asymptote. So basically we have three kinds of asymptote: vertical, horizontal, and slant. And horizontal asymptote and slant asymptote are mutually exclusive. Si we have horizontal, we have no slant. And si we have slant, we have no horizontal. How do you know that? Well, again, we are doing the analysis of the degree. Suppose example 6. Suppose we have a function like that. It's given. And you are doing the analysis of the degree. Always the degree of the polynomial in the numerator is 2. The degree of the polynomial in the denominator is 1. Entonces, when the degree of the polynomial in the numerator is bigger than 1, no 2, no 3, no 4. O sea, suppose que the degree in the bottom is 2, entonces the degree in the top should be 3. One more. We have a slant. Otherwise, no. Otherwise, no. It's very, very picky the condition, right? Now, to find the slant, we need to do the long division of the polynomial. I want to refresh your memory. Long division, long division, long division. Okay, then let me try to refresh your memory about long division of the polynomial. Entonces, en long division, we using this format. Inside the box, you put the polynomial and the numerator, this guy. Okay, and you organize like that. X squared is the first guy. Plus 0x, because x alone, so degree 1 is missing in this polynomial plus 1. This is important, extremely important, this organization. Because you write like that, you are lost. No. You reserve one column for the square, one column for the degree 1, one column for the degree 0. Okay, so outside the box, you put the divisor, is this polynomial. Okay, let's do it. So what is the expression here? Okay, multiplication by, okay, look, I try to find one expression. Okay, multiplication by x give me x squared. Well, it's obvious que es x, because x times x is x squared. I copy here in the first column. I did the multiplication this and this. Now I did the multiplication this and that. X times negative 1 is negative. Yeah, I put, because I have x degree 1, I put here negative x, or 1x, whatever you want. It doesn't matter, this one, it's invisible. Now by subtracting, you change the sign. Maybe you ask me, well, professor, what is the reason I subtract? Well, exactly the same we are doing in elementary school. When you divide 5 divided by 2, 2 times 2, 4, subtracting 1. This is the procedure for the division. The procedure of the division is multiplication and subtraction. Multiplication and subtraction, always. Always is the same. Do you remember that or no? Okay.
Yes.
Now, subtraction, that part is cancelled out, and this is just x. It's 1x, no? 1 plus 0 is 1x. Bring down 1. And we finish, no? Why not? Because you finish when the remainder, this polynomial, have degree less than 1, the divisor. The degree of this guy is 1, and you finish, you stop when you get degree 0. And the remainder. In this case, no, because degree is 1. Right? So no, we continue, we keep going. Now, what is the next step? Well, the next step is I try to find another expression. Okay, multiplication by x give me x. It's 1. 1 times x is x. And 1 times negative 1 is negative 1. And by subtracting, I change the sign, always systematically, multiplication and subtraction, multiplication and subtraction. This is cancel out, and 1 plus 1 is 2. Okay, I finish. Therefore, I prove algebraically que this expression, que es x squared plus 1 divided by x minus 1 is equal x plus 1, que is the quotient. This guy is called a quotient. Okay, okay, in our example of the elementary division, the quotient is 2, no? So actually, you express a 5 divided by 2, it was the operation that we are doing, like a 2, a mixed number, 1/2. This 1 is the remainder, look, and this 2 is the divisor. On exactly the same way I'm doing here. I copy the quotient, okay, the quotient is x plus 1. I copy the remainder, que is this guy, que is 2, and the divisor in the bottom, x minus 1. For sure, these expressions are perfect equivalent. These expressions are perfect equivalent. It's the same thing. There, but what is the difference? I can see clear like water que that part represent the slang asymptote. Okay, so the slang asymptote is, the formula is y equal x plus 1. Okay, I see que it's a line, no? Because I know que the equation for the line is mx plus b, no? So when you are doing the graph by hand or in Desmos, no? Okay, we have b1 in our specific example. This represents the y in a set, 0,1. And the slope is also 1. It's a coincidence. Entonces, slow, you know, slow is wrong and rise wrongs. Entonces, es 1 in our specific example. Now, wrong is 1, rise is 1. Entonces, 1 up, 1 to the right. We get the second point, and we connecting. And this is my dotted line, my slang asymptote, que is y equal x plus 1. In this example, bueno, we have also a vertical asymptote. Bueno, es obvio que the vertical asymptote is this. Remember the vertical, refresh your memory. The vertical asymptote is the 0 of the denominator, no? And the denominator at the beginning was x minus 1. So x minus 1 equal to 0. So the formula for finding the vertical asymptote is easy. It's to take the polynomial q, p divided by q. You take the polynomial q and force it to be 0. So for x is 1. So we have n1, 1 vertical. So that problem contain 1 vertical and 1 slant. Okay? Let me see in Desmos to see more clear. In Desmos. Okay. Let me share the screen to Desmos. Okay. I suppose it's this. Good. Very good. Okay, do you see this one, right? That was the previous example. Okay, now the new one. Bam! Look at that. We have, this is the original function in blue color. I plot auxiliary contractions. The slang asymptote gets the line y equal x plus 1. Look, this line. And the vertical asymptote was the line x equal 1. Entonces, you see que this auxiliary contraction help me to understand the complicated rational function. Do you see very well or no? Do you see very well or no?
Yeah.
Okay. Okay. Entonces, this is a moment in which I want summarize everything we should do to do the graph of the rational function, step by step. We have several steps. In that moment, you see the whiteboard, right? Okay, this is graphic. I want to call graphic a rational function. Okay, ready. Okay, this is the guideline. You are doing always my recommendation step by step, exactly using this step. Okay, actually, we memorize this step. Step one. On step one is the most important step. You factorization, so they are polynomial with no common factor. So to start the problem, we need that situation. Suppose that we have one polynomial, okay, I did the factorization, and this is x minus 2, x minus 3, minus 3, x minus 2, x minus 4. Wow, yeah, I did the factorization, yeah, I cancel out the common factor. And we're working now with the remaining part without common factor. Because I know at x equal 2, we have a whole. Okay, the step one, the most important step is factorization of the polynomial in the top, factorization of the polynomial in the bottom. If it's there, common factor, you delete, you cancel out. And you know that this guy gets gone as a whole. And we working with the rest of the expression. Okay? Step two is important, is find y-intercept. And what is the formula for finding the y-intercept? You evaluate the function n0. This is the formula. And this is an important point, extremely important. Secondly, find x-intercept. X-intercept is f of x equals 0. This is the formula always for any function, but specifically in rational function gets a polynomial divided by another polynomial, and this fraction is equal to 0 is because the responsibility to be 0 is because p is 0. If you ignore totally in your mind q don't participate in the game. You take the top part equal to 0. You set out this equation and you solve this equation and you get the x-intercept, que is the point in which the function, in which the curve crosses the x-axis. Number four, find the vertical asymptote. Remember, vertical asymptote, the formula for finding the vertical asymptote is you take q, no p, q equal to 0. You solve this equation. And when you solve this equation, the x value you use it to create the vertical asymptote. Okay, suppose we have 2, 3, 1, depending on the problem. This is in that moment, I don't know why I like so much plot the x-intercept. Look, suppose we have 2, suppose hypothetical, and we do vertical asymptote. Okay, let's continue. What is the number 5 step? Number 5 step is horizontal. Horizontal or slant. Remember, they are mutually exclusive. If we have horizontal, we have no slant. If we have a slant, we have no horizontal. But both, no, impossible. And how do you find that? Well, using the analysis of the degree, no? Analysis of degree, analysis of degree. Degree at the top, degree at the bottom. See, it's the same. We have, it's a regular case. When the degree at the bottom is bigger than this, it's a special of y equals 0. Oh, no, maybe we have no horizontal, we have slant. Yeah, I know, we have a slant. when the degree of the top is bigger than 1, the degree of the bottom. So it's in general, I summarize this information with the phrase analysis of degree. And don't forget, investigate the important point in which the curve crossed the horizontal axis or also crossed the slant. It's possible in both cases. Okay, this is important point, extra point. So we have a super important point. Y and Z, super important. X and Z, super important. And this point cross it, super important. If exists, but not always exists. Okay, almost we finish. Number 6 is analysis of symmetry. This is important. Determine if the function is even, if the function is odd, or if the function is neither. How you find that algebraically? Well, you are doing reflection. See, when you perform the reflection, the function stays the same. It's because it's even. And then we have symmetry with respect y-axis. See, when you are doing reflection, it's a completely opposite sign. So we have symmetry also, yeah, it's special. But symmetry with respect the origin. And neither is nothing. No symmetry. What is important is? No, it's not what's the time. It's save time. Why? Because you investigate the function is even. It's symmetric with respect to the y-axis. Therefore, you save time because suppose the curve look like that, the other curve is symmetric like that. Therefore, si you evaluate one value x, you get one value of the y, the opposite direction, que es negative x, is exactly the same value. O sea, in conclusion, you care only the positive guys because the negative guy is the same. Okay? In odd case, similar situation happen. If the function is odd, suppose que es something like that. Entonces, symmetry with respect to the origin. I suppose que es something like that. Entonces, you take one value of the x and you get one value of the y. When you take negative x, you get exactly the same value but opposite sign, negative 1. There is a reason que es negative outside. So you take advantage because the last step is number 7. Remember, we have 7 steps. I need in the test 7 steps. The 7 steps is plot additional points. How you select the point? How many points we need? How you select? Well, my recommendation is, in the moment that we are doing this roughly sketch, we have, for example, 2 vertical asymptote number 1, vertical asymptote number 2, and we found 2x intercept. So the minimum requirement, the minimum value, the minimum amount of the additional point you plot is 1 here, 1 here, 1 here, 1 here, and 1 here. It's a minimum. So basically, the vertical asymptote and the x-intercept create partition in the x-axis, and you pick one arbitrary before and after. Okay, and this is super easy because it's just evaluate totally randomly. Another student select different, and you plug it into the original function. This is calculated, and that's it. Okay. Too much, too long. Sorry. This is the guideline that we are using in any problem to do that. Let me spend the rest of the time doing at least one problem. Okay. This is the big example one. Big example one. Okay, do the graph of the following function. F of x equal 4x divided by x squared minus 4. Okay, this is given, and my question say do the graph of this. Okay, let's do it step by step. Step one is factorization. Well, in the top is monomial, we cannot do anything. However, here, yes, it's possible. Binomial is the difference of a square. The factorization is 2 plus or minus. End the story. I put in factory 4, factory 4, factory 4. However, I can see that we have no common factor to cancel out. No. Therefore, in this problem, we have no whole. We have no whole. And this is very frequently happen. Sometimes no, but sometimes yes. Secondly, y and z. What is the formula? Evaluate the function as 0. When it's super by 0 squared minus 4. Well, 4 times 0 is 0, and in the bottom minus 4, but the answer is 0. When this situation happens, 0, 0. Look, this is the x value, and this was the y value you take after the evaluation into the function, plugging in, x, y. And when this situation happens, 0, 0 is both. It's x in a set and y in a set. It's not frequently, but sometimes happen. Okay. The third step is find the x in a set. X in a set, the formula is f of x equals 0, or equivalent to say p of x equals 0. And p, remember, is the polynomial in the top, this guy. So basically, my equation is 4x equals 0, divided by 4 both sides, x equals 0. Confirmation. The point 0, 0, the famous, remember, this was the y, okay, you enforce it to be 0, and you get the x equal to 0. This is the x, and this is the y. Conclusion, guys. In this example, we have only one intercept, okay, by coincidence, it's the same. 0, 0 is the origin. Any question? Anyone follow me or no? Confusion or clear? Hey, answer me.
It's clear.
It's clear. Let's go to this number 4, que es baric acid. Baric acid, remember, you take the polynomial at the bottom equal to 0. I don't know if it's good for you or no. Take the original, or the factor 4. Personally, I prefer the factor 4 because it's easy. Actually, it's x plus 2, x minus 2 equal to 0. Therefore, we have two linear equations, and the value is -2 and +2. This is the crucial moment I like so much, to make one sketch by hand, no Desmos, for a moment, in which you located the two baric acetone. Okay, this is 0, 1, 2, 1, -2, baric acetone, baric acetone. Baric acetone number 1, baric acetone number 2, and why no? I plot that famous point, 0, 0, 0, 0. So we have the partition, and in the last moment, I need to pick arbitrary additional point. I pick one guy here, I pick one guy here, I pick one guy here, I pick one guy here. Okay, good. Let's move on to number 5. Number 5 is the analysis of the slant or horizontal. Let me copy one more time my function. My function was f of x equal 4x divided by x squared minus 4. What do you think? We have horizontal or no? Or we have a slant? What do you think? A slant? No. Analysis of the degree. What is the degree of the polynomial in the top?
1.
1. What is the degree of the polynomial in the bottom?
2.
2. Ajá, entonces, let me recall. When the degree is the same, we have a slant, horizontal. When the degree 2, 2, 1, 1, 3, 3. When the degree of the denominator is bigger, in this case is bigger, we have horizontal asymptote, but it's a special case. Okay, you need to remember this, no? Or you see in your note when you are doing the test or when you are doing Alex. Okay? Let me recap. Horizontal, 2 cases. When the degree is the same, or when the degree of the denominator is bigger. End of story. Elan no. Elan is when the degree of the numerator top is bigger than 1. No, we have no slant, we have horizontal. By the way, y equals 0 because it's special. Therefore, my horizontal asymptote look like that. Okay. Number 6, prove quickly algebraically si es even, odd, or neither. Even, odd, or neither. When you make a reflection, reflection means that you change the sign, you replace x for negative x. And you manipulate a little bit algebraically, and you see when the exponent is even, is positive. So I can conclude that this minus that I see in the top, you put in the front. However, it's obvious that our function is odd because when you make a reflection, it's opposite sign. No, it's twin brother, it's opposite sign. Therefore, maybe my function, when I put the y-axis, maybe, I don't know, I have no idea. I put in decimal now, look like something like that, right? Look, do you see the symmetry? This is symmetry with respect to the origin. How do you know that? Suppose that you plug in this value. Give me this value, que es negative. The same value you plug in here is the same high, but opposite sign. The typical odd symmetry. And the rest is plot the point. Well, just select different point. Maybe you select, see, this is 2 and this is negative 2. I select maybe 3. I'm using green color. Totally arbitrary. 3, 1 is good, negative 1 is good, but not necessarily negative 1 because I know that negative 1 is exactly the same positive 1 but opposite sign because I take advantage the symmetry. Okay, let's see the graph in decimal, the nice graph in decimal. Okay, definitely remember we are doing the graph in decimals. And also, you know, because you are doing before. Okay. Do you see decimals? Or what's the previous example? Now, my new example is something like that. Look. Bang. Look. We have, let me analyze. We have two, well, two no. We have only one x in z and y in z, que es 0,0. You get 2 vertical asymptotes, look, in positive 2 and negative 2. 1 horizontal and y 0. Okay, by the way, cross it in 0. 0 is y in z, x in z, and also the famous point, okay, the curve, blue curve, crosses the horizontal asymptote. And also we, of course, select arbitrary. For example, if you select 4, I'm plugging it into the formula using the calculator, of course. The answer is 1.3 repeated. And negative 4 is exactly the same value with the opposite sign. Okay? We take advantage of the symmetry. Unfortunately, it's neither. We need to work separately the positive part and the negative part. Do you understand very well? Very well or very bad? Well, I promise que next time we are doing one more example. Don't worry, because in the review package we have at least 3 examples more of the graphic of the rational. Okay?
Thank you.
See you.
Good day.
Mm-hmm.